Thank you for joining me to the Taking Application Security Insights to the Next Level with Fabric and NeoSemantics session. My name is Gal Engelberg. I am an applied research team lead at Accenture Cyber R&D Labs, located at Israel. We are doing a lot of cool stuff in the lab around applications of AI and knowledge graphs, especially in the cybersecurity domain. Today, I will be speaking about how we have taken application security findings and we augmented it using public repositories. First, I will talk about the needs and challenges. Then I will speak about the proposed approach, utilizing Neo4j Fabric and NeoSemantics under the hood. I will deep dive a little bit to cybersecurity ontologies, and then I will show how we take application security finding and augment it with further information and recommendations about adversarial techniques and countermeasures and more. So let's go. Okay, so recently, a lot of exploits have been detected, especially in open source software packages such as Log4j. All of these incidents increased the industry attention to scale up the application security monitoring. And in order to do so, organizations are using scanners or any other collectors to discover vulnerable software components. However, these scanners discover flaws in the code and they miss the mapping of the flaws to potential threats. And there are a lot of questions that we could ask based on this discovered flaw. First of all, how could an attacker exploit the detected flaw? And which countermeasures an organization could use in order to prevent this exploit? In order to answer these questions, we propose the following approach. We build a knowledge base based on publicly available data repositories of multiple cybersecurity resources such as D3FEND, MITRE ATT&CK, OWASP, and more. And then we take application flows and we utilize these knowledge bases in order to augment the finding report with attack patterns, attack techniques, and countermeasures. So before I will deep dive into the details, I want to highlight some of the technologies that we use under the hood. First, I want to describe a little bit Neo4j Fabric that is used. In one sentence, Neo4j Fabric is a way to store and retrieve data in multiple databases using a single Cypher query. It has two main use cases. The first use case is data federation, which is the ability to access distributed data in the form of disjointed graphs. Okay, this means that we have multiple databases with multiple schemas. The second use case is data sharding, which is the ability to access distributed data in the form of a common graph, which is partitioned across multiple databases. Okay, in that case, we have multiple databases with a single schema. In the showcase that I will demonstrate right away, we show how we use the data federation use case of Fabric. Another capability of Neo4j that we are using is NeoSemantics, which in one sentence is a plugin that enables the usage of RDF or other associated vocabularies within Neo4j. It has some key functionalities. The first one, and the most important to our use case, is the ability to import and export ontologies and taxonomies, which are the representation that is well used in terms of knowledge bases and more. And there are other vocabularies that could be used, such as OWL, SCOS, and RDFS. The second functionality is performing graph validation with shackle constraints. And the third one is performance of inferencing based on the ontology. Okay, so after I described in high level the technological stack that we are using, let me deep dive into the details. You can see here how this is done, basically based on information fusion. In very, very high level, we take concrete collected information, you can see here on the top, and we use public knowledge repositories in order to retrieve information regards attack techniques and defensive techniques. Here on the left, you can see the ontology of the application security findings. It has information about the application, the modules of the application, whether it's a first-party module or a third-party module, and each module has findings. These findings are mapped, probably by the collector, to either a CVE or a CWE. Here on the bottom right, you can see the ontology that was retrieved from OWASP, which is basically part of OWASP OdTM, which is an incubation project of OWASP. It has information about CVEs, vulnerabilities, their reference to CWEs, and their reference to attack patterns, and the corresponding attack techniques. And here on the top right, you can see the D3FEND ontology that we retrieve from the MITRE attack and MITRE DFEND project. It holds information about attack techniques, how they compromise digital artifacts, and how these digital artifacts are being defended by defensive techniques, or in other words, countermeasures. Okay. After we collect all of this information, we perform information or knowledge graph fusion. Basically, we map the shared entities across all of these ontologies, the CVEs from the application security finding ontology to the ODTM ontology, and the attack technique from the DFEND ontology. And in that way, based on a single Cypher query, we are able to take a single flow finding and to traverse all of the related attack techniques and the related defensive techniques. And this is how it's done in terms of architecture. This is the ontology-driven data federation architecture. You can see here on the top that we build basically a knowledge base based on public knowledge repositories. We take OWL files, which are given by the vendor of the data source. We take the ODTM OWL file and the DFEND OWL file. We load it via NeoSemantics, each one to a different database. And then we take the application, we scan it using some standard scanner, application security scanner, and then we transform the finding report to OWL, and we load it as well to another database of the concrete collected information. Then we configure all of these databases as a single fabric database, and we are able afterwards, using a data federation query, to retrieve all of the relevant information for each finding that was discovered within the application, to the form of an augmented finding report. This is an example of a finding knowledge graph. You can see here, basically, it's a graph that represents the finding report. Yellow nodes stands for applications. You can see here red nodes that stands for modules. You can see here brown nodes that stands for findings. And you can see that the orange node stands for the mapped CWEs for each finding. And then based on this query, this data federation query, which is composed of 3 components. The first component goes to the application security findings database, and it gets the finding and retrieves the related CWEs. Then based on the retrieved CWE, we go to the ODTM integrated model, OWASP ODTM integrated model database, okay, within the fabric. We take the collected CWEs and we retrieve all of the related attack techniques. And then based on all of the related attack techniques, we go again to the fabric into the D3FEND database. And in that place, we take all of the attack techniques and we retrieve all of the related digital artifacts and defensive techniques. And then at the end, we return the augmented report. This is an example of an augmented finding. You can see on the left, this is a finding that was discovered on a showcased application, DVWA, on this module, view source PHP. We discovered in line 53 that there is a directory traversal which is mapped to CWE 73. Based on our method, we were able to enrich this finding with the following information, with the related attack pattern, which enables the following attack technique, which compromises this digital artifact and could be defended. You can see a specification of detection and isolation based on these countermeasures. Okay, so what have we seen until now? We've seen that NeoSemantics and Fabric are useful to build a knowledge base from public repositories. And these knowledge bases could be used to automatically augment application security finding reports with further recommendations, such as attack patterns, attack techniques, and countermeasures. Thank you very much.
Yeah, thanks for great presentation. So we are running out of time. We have only 2 minutes. So we have any questions? I don't think so. We have a questions. Yeah. Thanks for your time, Carl, and thanks to all. So we will start in shortly with another presentation. Thanks to all.